internet today is mainly about content. Every day, 4 million hours of content is uploaded to YouTube and 6 billion hours is downloaded from YouTube. In addition, there are 5 billion Google searches every day. This is an amazing amount of knowledge and data that's available from the internet. Also, this content, 90% of this content was uploaded to the internet since 2016, so the amount of data, the amount of content is increasing exponentially. In the RIFE project, we wanted to make sure that this content was available to everybody, even to remote communities. We also wanted to examine a new protocol for accessing this content more efficiently, more cost effectively. This new protocol is the information-centric networking protocol. We achieved this by using 5 remote villages near to Barcelona that were our field trial, what is in fact the largest field trial of information-centric networking in the world. As a further achievement, the local team that helped us build the network and manage it, are now founding their own company to extend the network and to find new customers in this area. So this is also a further achievement from the project.
In the socioeconomic validation of RIFE, we first studied the bottlenecks slowing down the diffusion of internet by taking into account socioeconomical, regulatory and technological aspects. Based on this study, we generated what we call the socioeconomic APIs, which we use to evaluate technologies and network architecture, making sure that they keep network costs under control, they guarantee market competition, and at the same time enable operators to get subsidized. So we have applied these socioeconomic APIs to the different technical components and technologies of the RIFE architecture, including the IP over ICN technologies, the DTN one, and also some backhaul multicast functions. And as a result, we have proposed 2 new operator models and value network configurations. Through these operator models and new technologies, we are aiming to accelerate the diffusion of internet services in rural areas and in emerging markets.
In RIFE, Thales Alenia Space has studied and designed innovative solutions and concepts for content delivery applicable to the RIFE satellite backhaul strategy. We successfully tested those concepts over an emulated satellite platform because they required some changes on the handling of the data traffic and that existing ground SATCOM devices available today could not support. This solution aims to deliver content at low, if no cost, for people or communities in regions where paying a regular internet access is not affordable. In this scheme, we introduce a service for a category of usage without a paid subscription we call opportunistic usage. In such model, no backhaul resource need to be allocated to those services unless there is absolutely no impact for other regular service and paid service in terms of satellite radio resource capacity. For example, the satellite capacity can be used at night or during the day if the satellite communication system reports fuel load. The principle extends the quality of service concept integrated with edge caching and multicasting through several integrated innovations. Finally, we hope these emerging technologies will help developing the impact of the RIFE projects towards the goal of reaching free internet access in all regions that deserve it.
At TEEMU, we work on delay-tolerant networking, and these are networks that are composed directly from meetings between different devices. This is in contrast to more classical approaches to networking, which are based on building infrastructure that connects distant points to each other over long distances and allow almost instantaneous interactions. And in the context of RIFE, these types of delay-tolerant networks are important because some of the use cases that we look at, the deployments might be in remote areas. For example, a school in Africa, where the part of the network where the users connect to might not be well connected, at least not in the beginning. So in those kinds of environments, we can still provide connectivity by using these direct interactions between people to physically carry the data around and physically pass the data from device to device. And we can provide web applications, we can provide new native applications that work on this kind of message passing paradigm instead of direct end-to-end paths like IP networking.
Satellite communications address the need for ubiquitous access and the objective of connectivity inclusion by reducing transmission costs, whilst also increasing efficiency, flexibility and reliability. Satellite multicasting is also exploited within RIFE. Through this technique, backhaul bandwidth is utilized in the most efficient and cost-effective way, addressing the limitation of distributing information content at the same time at multiple sites that are geographically widely dispersed. Satellite multicasting, in combination with the ICN and DTN technologies developed within RIFE, solves the last mile bottleneck experienced in wired networks and further enhances the affordability aspect of the Internet for everybody objective of RIFE. RIFE's integrated architecture can be exploited to address multiple use cases across various sectors such as education, e-health, disaster management, and experience sharing, especially in underserved areas, which is a key market for Avanti's HILAS satellite fleet.
We at InterDigital are really excited about the outcomes of the RIFE project. We have tested our IP over ICN solution and found a significant reduction in costs. We have tested our surrogacy management solution, we have tested our edge caching solution, and these have given us particular insights into provisioning services locally, into reducing costs of the services locally. We have also planned to extend the trial by developing our own solution called FLIPS, which takes ideas developed at the RIFE project and extends it into our platform called FLIPS, and we hope to extend this trial to test this platform.
GIFINET led the field trial part of the RIFE project, and this essentially involved the design, deployment and operation of the field and experimental facilities. The design was made in collaboration with the rest of the partners, and the output was the specifications of what had to be implemented afterwards. The deployment, initially, the first part of the deployment was to translate these specifications into an actual network deployment, and the second part was the installation of the hardware selected. We made two deployments, one in a laboratory in Barcelona and a second in the field in Tarragona. The Barcelona's was a partial replica of the Tarragona's, which was the actual field trial involving end users. And the operation of the experimental facilities essentially involved the maintenance of what had been installed, the reconfiguration to suit partners' needs for their experiments, and also to coordinate these experiments in the time frame.
You'll hear more about the technical achievements in the later presentations, but at this stage I would just like to thank the European Commission and the Swiss funding authorities for funding the project, and of course the partners for their really intensive contributions to make this project a great success.